for women, Pyramid Coimbatore, to deliver the talk on the topic topological data analysis. Ma'am, please. Cecilia, ma'am.
Morning, sir.
Yeah, morning. Please share the presentation.
Yes. Sir, you have to disable the screen sharing for me, sir. I'm not able to share the screen.
Okay. Understood. Okay. Is it okay now?
Yes, sir.
Okay. Thank you.
Good morning to all. Hope the screen is visible to all.
Yes.
Yes, sir. Yes. So, good morning to one and all. So, first, I would like to thank the organizers of this international conference for giving me an opportunity to take the tutorial session. And here, the topic what I have felt here is topological data analysis. I'm going to just give you a brief introduction on what is topological data analysis and how it is working on topology with the data. Yes. So this topological data analysis, which is TDA, now it is an approach of analysis of the data sets. We use the techniques from topology. So it's only we are going to analyze all the data sets using the techniques from the topology. Now, by extracting this information from the data sets, which is it will be highly dimensional, then it is incomplete and it is very noisy. And it is going to be a challenging one to extract information from these data. So now this TDA, that is the topological data analysis, provides us a general, it gives us a framework how to analyze the data sets. So here, by the definition, it goes like this: a branch of applied mathematics that uses the notions and techniques of the set of scientific fields. For example, first we start with the algebraic topology, where the concept is used, and then we step on to this computer science details, and then finally, for the analysis part, we go in with the statistics. So the initial part of topological data analysis is nothing but the motivation is only to study the shape of the data. So first the data is analyzed, and then we use a topological property, and finally we give the analytical results. So the goal, the main aim is to apply topology. So now important application of topology where we are using the data sets. So it develops tools for studying qualitative features. First, we'll talk about the qualitative features, and next the quantitative features. So first, the qualitative features of data. The data, what we have collected as a data sets, it has a shape. Then the shape has some meaning, and then from the meaning we derive the values. So this is how we analyze the data with the shapes. So the data what we have collected, we are going to make it as a shape, and that gives us some meaning, and we are going to use the topological concept, and then by the statistical analysis we will be giving the result. So when coming about of the data, we have two data types. So first thing, the first data, it goes with a finite set of points. So you have a data, first we are going to make them as a finite set of points. You can see all these points in an n-dimensional space. So that would be the first data type what we are going to discuss. And the second thing, the second data type is going to be the function, where you take X to be any space and R to be our Euclidean space. So based on these two data types, the data have been analyzed. The first, that is the finite set of points and a function. the next. So TDA, what the topological data analysis is combining the algebraic topology and the other tools we are taking from the pure mathematics, and this allows the study of data. So here we can see the qualitative features. As I told you, first the data. From the data we take a shape. From a shape we are going to get some values, and these are some examples for the qualitative features of point cloud data. So what is this point cloud data? It is nothing but what? Sorry, am I audible?
Yes.
Sir, am I audible? Excuse me, sir.
Yes, ma'am. Please continue.
Yeah, okay. So now let us see what are the examples of this qualitative features of this point cloud data. So we are taking the point cloud data in a two-dimensional figure. So point cloud data is nothing but the finite set of points. You collect all the set of points in this Euclidean space. So that forms all this set of points. This forms a clusters. You can see there are three types of clusters here with all the set of points. Similarly, the second goes with the cycles. Even this set of points are formed as a cycle. Third one, it is nothing but the tendrils. So these are the three examples which I have given for the point cloud data. So next, so we'll see how do we use and when do we use this topological data analysis. So when do we analyze the data? When the data is very complex and it is high dimensional data, and then it is complex. And next, so extracting shapes, that is the patterns. We need to form the patterns from the data, and then we are going to collect what all the quality information is required for the data, and finally we summaries. We are going to get all the summaries, and which is going to give us the choices for the parameters. So this topological data analysis, where it is combined, as I told you, it is combined with algebraic topology. And here we are going to take the data, which is going to be very high dimensional, and it is going to be very noisy, and we are going to extract the shapes from that, and finally we are going to get qualitative informations. And then now comes algebraic topology. So here the concept what we use here is algebraic topology. So algebraic topology is nothing but, as what we all know, it's based on, for example, it is nothing but from a branch of mathematics we are going to use. The tools we are taking it from the abstract algebra to study the topological spaces. So to study these topological spaces, we have taken some certain concepts from algebra and we denote it as algebraic topology. From that algebraic topology, we take some Betti numbers. So I'm not going very deep into it. I'll just tell you what is Betti numbers are. This Betti numbers, we are using it to distinguish, that is differentiate between the topological spaces, which is based on the connectivity of all the n-dimensional simplical complexes. So this Betti numbers, we are using it to distinguish between them. The connectivity, we are going to have an n-dimensional figure. From that, we are going to see what are the connectivities which is based using the simplical complexes. So here we have defined Betti numbers as, you can see this denominator, like you can see the suffix as 0, 1, and also you have it as 2. So this Betti number 0 is nothing but number of connected components. How many components are connected? So that number is being given here. Similarly, when you go for Betti number 1, you can see that there how many number of, it is in one dimensional, and you can see the number of circular holes. So 0 will be only the connected, how many it is connected components, and 1 would be the one dimensional or circular holes. And this 2 is nothing but the void. It is nothing but the vacuum space which is created between the graphs. So these are the Betti numbers where we are going to use this and this geometry, using this geometric topology. Now next. So as we saw what was the quality information we get from a data, now just we'll move on to the quantitative information, what is required for the data to analyze using the topological concept. So as I told you, we are using a concept in topology, that is in algebraic topology, very specific. It is persistent homology. So persistence homology, is a special type of homology, which is we are going to use it for data analysis. For this data analysis. So Betty numbers, which has come from computing homology, as I told you, we are taking the homology of Betty numbers, which reflects our topological property for any object. So if you take here, I've given some example here, where I told you that beta 1, that is the 0 with the component, that is the connected components, and B1 is the number of holes. So you can see here, there is only one connectivity, therefore it is 1. Then if you can see there are 2 holes, therefore it is 2. Similarly, into the next one, you can see only one connectivity and 1 hole. So this is how you analyze the data using the Betty numbers. Next. So I'll tell you what is homology here. So you can look into this diagram. I've given you this homeomorphics to a picture here. This is a sphere. So if you go to the sphere, you can see number 2. So it is wide. So what will happen if all these points are closed? It forms a sphere, and there is going to be a huge space. That is a vacuum created inside that. So you say the void is 1. There is one void. Similarly, when you go with the plane, if it is for a plane, you can see there is no space or vacuum created. So we mark it as 0. So the same thing. So you can take this shapes. So there is a shape here as a hand, which has 5 fingers, and now a data has been extracted from this shape. So how do we extract the data from here? So as all collected finite set of points, these points are collected and we say it is a point cloud data. So this data, how we are transforming into a homology. So we use the persistent homology, Betty numbers, and finally we get the connected nodes. All these points are being connected, and it is as a. So the problems, everything are going to be some complex problems. We are going to take how we are going to build such simple complex problems. So that we have many ways to build them from a topological space. So here we take a homology that approximates one of the space that we need to study. So you can see all these points in the first figure. You can see the set of points which is all connected in different angles. Similarly, you can look into the second and the third. These are the 3 different simple complexes, the picture which we have extracted from the data. So this is how the concept of simple complexes goes. So you can see only one set of points. So I say that it is a vertex and I name it as x1 and it is 0. Now you have 2 points, so there becomes an edge. So there is a connectivity between them, and that is 1. There is one connectivity between these 2 points, and it is 1. So it is made as simplex. Similarly, you can go with the next. If you include one more point as x3, then all these 3 points are connected, and you say that it is 2 simplex, and it becomes a triangle. So it goes on like this, and finally you can see the simplex complex. The simple complexes are framed. Next, now the concept of persistent homology comes inside the topological data analysis. So here, as per the definition goes, you take the inclusion mapping from xi to xj, which includes a homeomorphic mapping here, says that x of xj to xi to xj, where this image is what we framed here is going to be the persistent homology groups. We are going to make them into groups. So with this persistent homology, what we are going to learn is, we are going to the study of homology. How do you filter them into a single algebraic entity? So we have all gathered all the informations. Now using this persistent homology, we are going to filter it up. So this filtration part, I'm not going to say it in detail, because again that goes with this. So how do we filter the homology to a single one? So that, how is it being structured? So we are analyzing using the persistent barcode. You have a persistent barcode, and from that we analyze the data finally to get the results. So its features can then be analyzed using its barcode presentation. And this is formally, you say it as a structure theorem. You can see the distance here for the barcode, and we have given you how the distance is being calculated for this barcode. So it is D1 and D2. So here, this shows how do you filter the data by using the homology. So you can see the connected nodes here by one. See, all the nearby points are being collected and it has been connected. All the points are connected and it is made into a graph. So the sequence of the simplical complexes with its inclusion maps is nothing but the filtration, what I told you. So this is how the filtration process goes on. So this idea is nothing but we connect all the nearby points and now we build up a simplical complex. So you can see the points all over this. So if you have a point, see all these points are collected and you frame a shape here. So this is how all the pair of points, there are no further, the distance according to this, all the points are calculated. And we have to see how this B is being chosen. So you can see here, you can see all this finite set of points is a cloud, but here which is taken as epsilon is 0, it means that there is no connectivity between these points. So when you consider this, see you have all these points what you collected, and I have gathered 4 points which are closer and I have made it as a connected points. So I take that as epsilon 1. Similarly, how many ever connectivities are given, you consider that to be 2, 3, etc. So now comes the barcode plays an important role here using this persistent. As I told you, we'll be drawing a graph with the barcode. So you can see this D1, D2, and you can see a lengthier barcode here, which says that in this filtration, after the filtration process, you have a simplical complexes in which there is a space created, an empty space which is created more than the information, than these two data. So what we are going to do is, analyzing using this distance graph barcode, we will be deleting the lengthier barcode that says that there is an empty space. It is a void. You have a void. So looking to this barcode, we can omit this set of data. So how do we connect from the point cloud data to the complex data? So what we have taken as an input is nothing but a finite set of points, and we have a notion to find out the distance between them. So that elements are mapped into the point cloud data. Now this point cloud data is nothing but it is continuous shape and complex, where you can see I've given you a picture giving all the data and how it has been given it in a set of points. All these points are shown in this bar, the graph, the set of points. And now next, all these points are being connected. And finally, using this topology, see, you can see this topology is formed here with all these points. And now with this complexes, we will be analyzing the results, and finally the results are given. So what are the further procedures after this? We have drawn this persistence diagram, and from this we first find out the stability results. What are the results based on this to be stable, and finally we get the statistical results. So this is how we implement our topological data analysis. First we analyze, that is, how do the topological informations are analyzed for different data sets. There are different data sets, and how do we gather the topological informations? So we have an application which is implemented using GUDI in Python, and similarly we have the topological data analysis in R, and then so all these three together we will represent for the implementation. So GUDI is an efficient tree representation of simplical complexes. We say it is a simple tree. So you can see here the simplical complexes 1, 2, 3, 4, and 5. These finite set of points has been transferred into a simplex tree with the nodes 1, 2, 3, 4 and the vertices, and this is being analyzed. So this is how it has been implemented, and for the conclusion I say that how it has been applied. So finally I conclude saying that this topological data analysis, first using this GUDI, the data are being collected and that is given into a simplex tree, and then the persistent homology takes place, and from this persistent homology we go in with Betti curves. That is, you can see this curve using this Betti numbers, and then the persistent diagram Then the persistent barcode, which clearly indicates the data's instructions, how it has to be carried out. And then finally, you can see from persistence, the bootstrap and the confidence band is created using this topological data analysis. So this is how the data has been analyzed using the concept of topology. So this concept is used in simplical complexes, computer science, and digital imaging. So the topological data analysis, the workflow is nothing but the workflow of this topological data analysis is first you collect with the point cloud data and then the nested complexes, and then we go in with the persistent homology, and then the persistent diagram or the barcode is used to analyze the data, and finally we get the result. So I conclude. I thank for giving me this opportunity. Thank you, sir.
Thank you, ma'am. Thank you, Shikla ma'am, for the tutorial. It was an informative session.
I now invite Dr. Rajagiri, Assistant Professor, Department of Mathematics, Rajagiri National Tribal University, Amarkandak, Madhya Pradesh, to deliver tutorial talk on the topic nature-inspired algorithm for optimization.
Hello.
Yeah, Rajagiri, sir. Please share.
Yeah. Very good morning to all. Sir, can I visual it? And my voice is clear?
Yeah, very good. Please share the PowerPoint.
Sure.
Okay. Right. It's visible, sir.
So it is good, sir. Hello.
Yes, sir.
Yeah.
Okay.
Okay. So very good morning to all. Good morning to all, and this is very for this prestigious and eminent conference, international conference on mathematics of intelligent computing and data science, ICMICDS-22. So my topic is, according to this conference, intelligent computing. So right now, in present day, some nature inspired algorithm are generated to solve the optimization problem, that is means which is generated in the real life. So these are the some outline. What is the meaning of nature inspired algorithm? And then we are discussed with the some advanced nature inspired algorithm, then some future work. So the thing is that what is the meaning is nature inspired algorithm, because among all the methodology, nature is the very best solver, and nature is provide the solution of all the problems which is generated in not in our daily life, among all the universe. So the nature, how should be the generated the nature inspired this algorithm? So nature, from for example, we have the nature having some process, some mechanism, because sun is coming in early morning, then night, then some insect is there. What is their process? So according to them, we think about the evaluation concept, their mechanism concept. Then we designed some methodology according to their mechanism. Then we design some methodology. That one is known as designed algorithm. And after design mechanism, because they are having some mechanism for what? mechanism for finding the solution. For example, in the sky we are seeing that why the birds are flying. Birds are flying, fish are schooling, ants are foraging. Why they are foraging? Why the fish are schooling? Because they are finding something. Finding what? Finding the solution. So according to their mechanism, we design some methodology. That's because they are dependent on the nature mechanism. So we says that these are the nature inspired one. So according to the mechanism, we are designed some perfect things. What is the process? According to the process, we are solve the some optimization problem after getting, because without inspiration, because whenever we get the inspiration, we are inspired from their mechanism. So whatever we generated, that one is known as nature inspired algorithm. So right now, which number of discipline is generated by the adapted by the researcher to generate the nature inspired algorithm. For example, if we now go for the biological section, in biology also number of mechanism is there in biological. So in that biological mechanism, number of percentage here written is according to the means some investigation, 54% phenomena is used to generate the nature inspired algorithm. From chemistry also, because they have the some analytical mechanism, some computation, music, mathematics, military, interior design, physics. These are the some areas from where we are inspired according to their mechanism. Then we generated some algorithms. So right now, what is the best criteria or best investigation to generate? Because the evolution is needed. For example, if you see in this slide, then the percentage of insects, if you see in this slide, then the percentage of insect is 23%. Percentage of the insect means whenever we generated some methodological section, then we see that in nature, the number of insects mechanism are working there. For example, whatever earlier says that the birds are flying, fish are schooling, ants are foraging. So why they are foraging, why they are schooling? So according to their mechanism, they are included in the part of insects, but they are the parts of the nature. That's why this is written as insect mechanism. Natural evolution. For nature evolution, then animals, birds, human, plants, etc. number of their. So whenever we are fully understood about their process, then we generated some methodological section. So according to their mechanism, nature inspired algorithm is divided, maybe this is not the division. According to their phenomena, we are divided into two parts. For example, evolutionary algorithm and swarm optimization. Evolutionary algorithm means some whatever the existed one, we are added something new, then the some evolution is there. That's why this one is the evolutionary. And swarm optimization means the swarm is, we are use the word swarm. This is the based on group of birds, group of insects. Though, so the word is swarm means group of birds, group of insects, etc. That one, this is known as swarm. So swarm optimization, whenever we say that the swarm optimization, then fully about that, this is the evolution through the some birds mechanism. So for example, if number of criteria is, number of idea is there, so number of algorithm is generated. But according to the phenomena, which one is because there is no algorithm to solve number of optimization problem. According to no free-lunch theorem, some theorem is generated. So according to that one algorithm, no one is perfect to solve, because at the time of in Darwinian principle, who is survive in this world? According to the which is one is the fittest. Darwinian principle says that survival of the fittest. So according to their, So which number of ideas to given the nature, but which one is generated good one. So according to which one maintain exploration and exploitation, means exploration which generated the number of points according to the flood in a search space, number of points scattered, and scattered according to their better position, they are swing their position to better one. Exploitation means whenever number of point generated going to the better point, then some points are maybe not reached to the global optimum, and at that time they are exploited and maybe stuck. So there are two conditions which maintain exploration and not the fully percent exploration and not fully percent exploitation. Which algorithm or which methodology is maintained these two things, that's why we say that this one is the good algorithm. For example, this one is the particle swarm optimization, and one is the algorithm in the part of swarm optimization. So if we see in the sky in morning, the birds are flying. Why they are flying? Because they are searching the food. Searching the food means they are finding the solution, because somewhere food is existed, but no one is known where the food. So Kennedy and our heart, what they did, according to their swarming behavior, the number of, but if the food is there, no one is there. So according to their mechanism, one food which is nearest in the food, that one word is informing to others. So that which word is nearest in the food, that one is known as global best, and the other one is known as personal best, because there are two conditions. For global best, which is nearest in the food, which is informed to others, and the personal best. Why they are personal best? Because they are ability to improve their own self position, because after some time maybe some birds are reached fastly instead of global G best particle. So that particle is converted into the global best. So because they have the ability or personal, because everyone, even in our real life, we are improving to our own position. That's why whenever they are improved the personal best position, then they are converted into the global best. That particle is maybe nearer comparison to the previous one. So there are two main steps in particle swarm optimization, because the particles are moving. When the particles are moving, then what will happen? They are generated, then one particle move one place to other, then the number one step is whenever some swarm is there. Swarm is group of words, means matrix. Simple name is matrix. Matrix generated according to the objective function. Whatever your objective, what is your problem? Then problem having some space. According to space, we are generated one matrix. That matrix is known as swarm. Initialize the swarm. Then updating the velocity, because whenever one particle move one position to other, then the velocity concept is there. So whenever the velocity is generated, then this one is the formula for velocity. According to formula, that one in right side, in left side, that one is the updated, because every time whenever particle improve or on position, then the position velocity changed according to these rest particles. In every particle we are generated some velocity initialized, but initialized time according to the swarm matrix, the matrix may be calculated because there is no changes at that time. Then some researcher, what they did, according to their position, they are put the initial velocity are 0, or they are decided again according to the search space. Then if you see here in this slide, then W into V is there. Then that V is the previous velocity, and the left side velocity is the updated velocity. Then the this one is there, P C1 R1 P best minus current, and C2 R2 minus current best. So this one is known as cognitive. The first component P best because there are three components. First one component says that this is the inertia component or velocity component, velocity where the velocity, previous velocity is there. And the second one is the cognitive component, and third one is the social component. Why this one is cognitive and why this one last one is the social component? This one is cognitive component because here, if you see here, P best minus current means the particle are ability to improve their own position. P best means our personal best position. Then that one is interact with the other position, other particles and improved own selves. That one, this one is the cognitive. And this one is the social component because here every particles are socially interact with the one best particle. That one is the social, because here the learning from the other particles. But in second component, the learning position is our own position. That's one. This one is the cognitive component. So that according to this one, here R1 and R2 are the random number to control the swarming behavior, and C1 and C2 are the acceleration factor, because the component whenever, because some limited space is there, then whenever we generated some velocity, there may be some bound out of the space. So according to they are controlling that particular factor according to their behavior. For example, W, this one is the inertia factor, that one is controlling the velocity. Second one, C1 R1, this is the component controlling the cognitive component. And according to this is the particular, because they are the parameters of the velocity. So they are better participation for the particular, for the different vector according to decision. They are decided, even they are decided the how should they participate. If they are means if you say that these are the constant value or some varying value, so behavior of the cognitive component or particular word are changed according to their C1 and R1, because this one is the accelerate their position. So if we see that in the velocity update equation 3 term is there, whatever we see is that we see in the previous slide, inertia term, cognitive term and so this term forces the particle velocity move to in the same direction, because W into V, whenever you combined or multiplied with the previous velocity is some constant or means a controlling factor, then how should we see that the particles move in the same direction? And this following is in the old velocity. If we see in the cognitive term, in the cognitive term, this term forces the particle to go back in the previous best position. Why this one is previous best position? When one particle or move one position to other, then that particle after some time maybe the position is changed. So that particle or remember the previous position, own previous position. That's why this one is learn according to means that particle are learn according to the previous previous position. So that's one is the cognitive term. And the last one is term is the, for example, cognitive term. This is a word having 100 unit foot in the initially. After moving somewhere, this word having 80 unit foot, and after again moving somewhere, this word having 50 unit foot. Then according to the cognitive behavior, this word is thinking, where should I move? Where is my solution is existed according to my movement? Then this word is moved to the where the maximum unit of the foot is existed, because that particle is learning with the own behavior. That's why this is returned into the best position, but the position change according to their behavior. In the cognitive velocity update, the third one is known as social learning component. So these terms are the particle move to the best previous position according to its neighbors. This is the very different varying difference in between social component and cognitive component. In cognitive component, every particle learn their own position, but here the particle are movement to better position, but learn from its neighbors positions, because they are learning from others. For example, this word having in the one space and where should I move? In the space means in the according to the objective function, that one word having 150 unit put, and the another word having 100 unit put, and the third one 100, and the last one. Then this one is learn from its neighbors, from the others. So this one word having moved according to their other positions. So that one move 100% word moved to the where should maximum unit is 400 unit put. So according to, so we updated the whenever velocity is updated, then we added the velocity with previous position. So we see that the position is updated. Velocity plus position means previous position. Then whenever we added, then we get the new position. Then we get personal best updation, because every time particles position is changed. Maybe the previous best position or current position is different. So according to the function value or better fittest value, we are also change the personal best position, because these are the some iterative process. What is coming in the next iteration? So personal best position according to the function, whenever the previous best having better fittest, then we are considered the previous one. Otherwise, we are consider the current one according to their function or better fittest function value. Similarly, we are changed the global best, because the global best position is also changed, because every particle movement their own position according to its neighbor position. So at that time, maybe some worst neighbor are improved according to their position. So they are converting into the global best position. So we are changed accordingly. Then some stopping criteria, how should they are terminate according to their, we are terminate. For example, how should we implement example mathematically? Because this is the very important. Then whenever we are seeing that in natural, then the question is coming, how should we implement? For example, here one slide example is there. For example, this minimize the function in x1 square plus x2, and that one function having them bounds, because the variable and some searching space is there, -5 to 5. If anything is anyone ask, then may interrupt, no problem at all. May interrupt and ask something and discuss something, there is no problem. So minimize this function. So for example, we are generated some matrix. Matrix means swarm. Here, if we say that generate the swarm. So generate the swarm means we are generated according to the random value. How should random value -5 to 5 are existed? Number of infinite number of random number. So according to the result, we are decided what is the size of the swarm. What is the size of the matrix? According to the size, we are generated one matrix. But the question is, how should generated the matrix? Because these are the random number. So number of idea to generated the matrix. For example, one idea is written in the research, some frequently used lower bounds plus rand in between 0 to 1 plus upper bound minus lower bound. Then the number of points are generated according to the rand position. Rand 0 to 1 terminate the every value in bounds and generated different number. So the generated, we are generated here a 2 cross 5 matrix. Then we are calculated the function value. So according to the function value, what is we see that because this one is the minimization problem, then which having the lowest value, lowest function value, then we see that this one is the global best condition. According to their behavior and the PSO behavior, this one particle, because these are working as the vector position or particle. If you say that this is the swarm, then what is their vector? Their vector is a particle. Their vector is the birds. So these birds, these are the words. So which one is the minimum? The minimum one is the second last row. So that one is rose, or that one particle is considered as the global best particle. So that's why written as G best, and the rest one is the personal best, because they are improving. They want to improve according to their position. If they want to improve, what is the procedure? We are generated again velocity. So don't worry about the velocity. How should you generate? According to their phenomena or according to the direction. And someone, if you want to know the particles are not initiated, so you put according to the size of the matrix previous. What is the size of matrix? This one is 2 cross 5 or 5 cross 2 the matrix. So we are generated one again matrix, velocity matrix according to their bounds. Again, if you consider the bound of the search, because velocical search space is again, if you think are taking the large space, then the generated between 0 to 1 or -7 to 7 are put it in the without initiation in first time. In iterative initialized time you put to 0. So again, for example, how should you are initiate the next one? So if you see here, what is our formula? According to the formula is that W into if you see that W into V1. So according to put, because the velocity generated according to V1, matlab that one is old, plus C1R1 P best 11 minus plus C2R2 G best minus X1. So what is the old velocity? Because the velocity update formula in the position, if we consider inertia, W component is there. If you keep in mind in previous slide, W into V plus C1R1 P best minus current plus C2R2 G best minus current. So according to, if we say that no, there is one component W is equal to 1, then we put first in this term there are three term, V11 plus cognitive and then social. So V11, that one is old. So where V1 consider the old, this one is the old velocity. So you put accordingly to V11 plus C1R1, C1R1 according to your research or according to the some recommendation, C1R1 is C1 and C2 we are fixed here, for example 2, and R1 and R2 are two random number. Then which one is the P best 11? P best 11 position, whatever you generated in the first one. So first one position is 2.7045. So you put accordingly to 2.705 minus X11, because there is no movement at that time. So best position and the initial position are same. So we are put accordingly to 2.7045 minus 2. Plus then C2R2, C2R2 again 2.0.6, and the G best, here G best is changed. Why? Because this is changed, because here the position is 1.6400 and this one is the according to the string or row. So if you go for the row, that one is the best position in which one row? 1, 2, 3, 4th row. 4th row, if you say, then put according to the G best value 1.6404 and G best minus current, so 2.7045. Then our calculation is coming with V11. Again for V12, V13, how should you generate it? According to the whatever you decide the matrix in the swarm. So the same size of the matrix generated the V11. Then again generated X11. So this one is the V11. What is the new position for this particular particle? X11 old. X11 old means this position 2.7045. Then new velocity V11 new. So what is the new velocity is? We are calculated minus 1.3557. So whenever you added this velocity and the previous one, previous old position, then you get the new position. Similarly for other component, other particle, other words, you are calculated again velocity for V12. You calculate new velocity, then added with the same position of the previous one position, then you add, then you get one new position. Similarly for all, what will happen According to the size of the matrix or swarm, you are generated one new matrix, one position. Then the position are changed. What is the first component of the previous one? 2.7045, 4.8030. And what is the updated component? This one is the updated component, new swarm, and that one is the old swarm. If you see in the slide, new swarm, what is the old swarm, old matrix? 2.70, what is our generations? What is the new one? So new one, 1 point, if you see that the row wise competition or row wise is that, then this one is the improved or changed. So again, we are calculated the function value. Then the previous one function value is 30.3831, and the similar component, similar string, similar row, we find that 2.5194 according to the, when we are updated accordingly, first we are generated the velocity, then updated the velocity and added with the previous old swarm, then we get the new velocity and the new position, new swarm. Yes. Hello.
Yes, sir. Please conclude, sir.
Yeah, sure. So this one is the updated swarm. So according to the, you are updated. So these are the some issues. If you say that number of particles are moving, then clamp the particle, stagnate the particle, then how should it improve? This is the bigger question. Controlling the velocity, is it the swarm size or the fixed? No. So what is the robust parameter? Means C1 or C2 is there, and then what is the control parameter? So the bigger question is that is how to choose the parameter. This is the very imminent and computing part of the research. So we have done, for example, we are generated these two new parameter, 3 new parameters, then we put and check. For example, this is one objective function, and what is the global optimization in between -500 to 500. Then we see that accordingly in first iteration, initialize, this is the swarm of initialization. Then we see that in the initialized position, this is the swarm, but after 5 generation, 5 iteration, 10 generation, if you are implemented this one, then you see that the particle or movement are better comparison to the traditional one. So that one is the iterative process, depend on the better and better fittest one. So this is the convergence behavior bit. What is the convergence probability according to their function? We see that the some convergence probability, because this is the not dependent on the only one population, because the other one is there. So which one is moving around for the same condition, same population, which is converges to move to fast to global optimum, that one is converges to where. So these are the some regulated result or some new simulation result for the same. So these are the some results. So these are the, but at the previous, why we say that if the diversity maintenance is not good, if you say that which one is the diversity is good. So for example, we see that in the, we see through the MATLAB code, number of crores of the population is generated. Then according to the movement of the particle swarm optimization, they are improving. Then what will number of crores particles even improving the global best position. Then the number of particle, if you see in this, that the number of particle moving and reach to there are global, then the global optimum, then maximum particles are moved their own best position. So after this one, some model, if we want to generate some model, because this one is the human intelligence, according to why they were in the playing cricket, playing volleyball, then what is the criteria according to their mechanism, we are seeing that these are the some insects, we are learn from their behavior and generated. For example, now we are working Drosophila mangosteen. What is the working position? So generated according to their position, what is the methodological section, and their methodological section checked with the working best and best position. Is it the true according to the methodology? Then we are generated some operators accordingly and implemented in some optimization algorithm. So this is the few things, are very few things, because the right now nature inspired algorithm is a very vast area coming in the near future. And this one AI is working better to better heuristic, because these are the heuristic and counted as the meta heuristic technique. So thank you very much to all of you for very listening carefully, and thank you very much to all.
Thank you, sir. Thank you so much. Thank you, Dr. Sir, for the informative session on nature-inspired algorithms. Thank you for taking effort in giving detailed solutions and examples. That was a very informative class. So we are a bit late. So we are moving to the top 5.
Thank you.
We have with us Dr. K. Paulos Jacob, sir, for the next session. Dr. K. Paulos Jacob graduated in electrical engineering from Kerala University with merit scholarship post-matrically. He completed MTech in electronics and secured PhD in computer engineering, both from Cochin University of Science and Technology, CUSAT. Joining CUSAT as a faculty in 1983, he was promoted as Professor of Computer Science in 1994 and was nominated as head of the Department of Computer Science, which position he occupied until 2013, when he was appointed as Pro-Vice Chancellor of CUSAT on a 4-year tenure. He was officiating Vice Chancellor of CUSAT during January to October 2014. During the period he was on the rolls of CUSAT, he held several academic positions like Chairman of 4 different boards of studies and Dean of the Faculty of Engineering as well as Dean of the Faculty of Technology. He has been a member of CUSAT Syndicate for 5 years, of Academic Council for 26 years, and of the Senate for 16 years. His interest in research includes topics in parallel processing, networks and information systems engineering. A recognized thesis supervisor of CUSAT, he has authored around 150 referred journal and international conference papers. 25 scholars have secured PhD from CUSAT under his supervision. He is a professional member of the ACM and life member of the CSI. He was chairman of the Scientific Computing Panel of the Naval Research Board under the Defense Research and Development Organization during 2016 to 2021 with the role of fostering national defense research. He served as accreditation ambassador under the University Grants Commission project of mentoring higher education institutions towards securing accreditation. He occupied the next chair professor at ARCET for a 2-year tenure since July 2017. Presently, he continues at ARCET as professor and dean. On behalf of everyone present here, I welcome you, sir, for this session.
Morning, all of you. Thank you very much for the exhaustive introduction. Aware of what I have for the participants who are online. They may like to know who the speaker is. So it is but essential that some introduction is made about the speaker. Well, I thought of talking something about social media. Perhaps you may wonder for a conference on mathematics on built-in computing and science. What is the relevance of social media? That perhaps needs some justification. The initial part will be to justify the topic. Please bear with me for that. We just finished a tutorial. Tutorial, as you know, is totally different. You are supposed to go intensively into the various things. Particles for optimization, algorithms, lot of equations, etc. One D1 would like that. Here I don't have any equations at all. Well, I must say I may not match the qualities of a good mathematician, though I have been a researcher in computer science. I cannot keep mathematics apart that I do agree. You know, there are several computer scientists who have been mathematicians as well, like Alan Turing, the founder of the concepts of artificial intelligence, even though he has not coined the term artificial intelligence. By and large, Alan Turing is considered as one who has brought up the initial concepts of artificial intelligence. That is why the famous test whether a machine is intelligent or not, what we call the Turing test, that has become very famous and it is propagated even now across the world. And I must also mention Turing Award. Probably you must have heard about Turing Award. It is something like Fields Medal in mathematics, almost compared to Nobel Prize. So Turing Award has been instituted in honor of Alan Turing. He was a mathematician, he was a computer scientist, and he was a philosopher as well. What is the relationship between computer science and philosophy? Well, if you look at artificial intelligence, there is a lot of reasoning that is likely to happen in order to get into some conclusion. For that, logic is very important. And that is why, if you go deep and deeper into philosophy, your mind will be tuned to a state where you can think very logically and arrive at very conclusive decisions. And see that everything can be explained in terms of philosophical concepts. That's why even for the curriculum on ethics, there is some part of philosophy also, isn't it? Aristotle, Socrates, and all that. You read about those people also. Anyway, let us come to our coming properly. Well, these are the components of what my talk is. Of course, as all of you know, when you make a presentation, it's always good to give a walkthrough of what you are going to talk about. This is jumping. I think I'll use this. So our conference is Mathematics of Intelligent Computing and Data Science. I want to start from there and reach our social networks, more particularly social media. You know what intelligent computing is? It attempts to mimic human intelligence through symbol manipulation and symbolically structured knowledge. That is the most basic concept of intelligent computing. How is it different from conventional computing? Conventional computers have storage for data as well as information in memory, and they apply algorithms on this data. You get information, probably you can derive knowledge about that, depending on what sort of algorithm you are giving, what sort of processing you are giving. So in all those things, essentially we are the masters. We give instruction to the computer to do certain things and you get some result, which would be intelligent depending on what you have given to the computer as input. As you know, there is a saying, garbage in, garbage out. You are giving garbage, what we get also will be garbage. So it is our responsibility to see that. Intelligent systems are technologically advanced machines that perceive and respond to the world around. Some amount of cognition is also there. We know what is happening around us. We have some knowledge. From that knowledge, we are able to go further and have additional knowledge and try to solve what problems we encounter. The ability to learn or understand, to deal with new and or trying situations through proper. That is what intelligent computing, intelligent systems. Anyway, that may be probably a review for this ability to apply knowledge to manipulate one's environment or to think abstractly as measured with objective facts. Well, towards the end, I will come to watch or how social networks or social media is growing. That's what I am attempting. When you look at intelligence, there can be naturalistic intelligence, logical and mathematical. Naturalistic intelligence, everybody has. Even a child has naturalistic intelligence at his or her level. But as and when you grow up, you acquire more and more knowledge. And that is where our logical, mathematical intelligence comes. So, as I said, you can't keep mathematics apart. If you look into computational intelligence, if you look into artificial intelligence, everywhere the basic component would be built upon mathematics and logical reason. That's why these days for this test enrollment conducted by companies and other employers, there is always a component of test of reasoning, test of logical thinking. That shows the level of your intelligence to some extent. Well, simulation of human intelligence processes by machines, especially computer systems, constitute artificial. Things you know. Intelligent machines can mimic human intelligence to perform tasks. That is the important thing. To have a machine, it should be able to mimic our actions, mimic our thought process. Some extent mimic our cognition also. And can literally improve themselves based on the information they collect. That's why this machine learning, deep learning exercise acquiring more and more importance. They are capable of learning from the environment based on an initial training given. Today, AI empowers organizations, governments, and communities to build a high-performing ecosystem to serve the entire world. It's clear enough. And here comes my crucial point. Its profound impact on human lives is solving some of critical challenges faced by society. So that is where we stand now. We have the society on one side, we have capability based on artificial intelligence, intelligence systems, mathematics, and all. How can we match the two? That is what I am trying to give. Some thoughts. I am not giving any results or anything. Let us look at one such challenge faced by society. Impact of social media. Social media can be viewed as online facilitators of human network which enhance social connectivity. That's what social media is. Why is it called social media? The term social with regard to media suggests that platforms are user-centric and enable community action. We are part of a social system. We are social beings today. So when you network among ourselves, that becomes what can be called as a social network. And the channel or the medium which supports that network is what we call social media. And a lot of applications have been built on the social media, which we are all using. I don't know if there is anybody who is not using social media at all. WhatsApp, every now and then we look into the WhatsApp. Somebody was saying these mobiles are meant for knowing things, knowing the time, several such information. But now we are spending our time on mobiles rather than using the mobile. You will be just, if you wait in the airport, if you wait in the railway station, we will just look into the mobile and spend our time. Sometimes it is educative also. But your thinking should be governed by ethics. Otherwise, it will be a disaster. Digital ethics is something which is again gaining importance. Anyway, these are all side shows, I would say. Well, the driving force of social media is its content generated by the users, which include, as you all know, text, posts or comments, digital photos or videos, and scientifically more prudent data generated through various online transactions. AI, now we have CA, you know, collective intelligence, using the social media. We can work as a group and provide solutions or step-by-step approach towards arriving at certain solutions. So that's what collective intelligence. So several terms are emerging from artificial intelligence. Collective intelligence is there. XAI is there. Explainable artificial intelligence. Because initially artificial intelligence gives decisions which may not be supported. How that particular decision has been arrived at by the machine. The person who has designed and developed the algorithm probably would know, but an end user may not know what is the reasoning that the computer has adopted in order to arrive at such a decision. That has got some legal consequences also. I come to that. So the driving force of social media is its content generated by the users. Okay, I'm talking about scientifically more prudent data generated through various online interactions that are collective intelligence. The influence of social media is seen extending to politics, business, world culture, education, careers, sports, and more. We see every day, we are reading in the papers. Who is the gentleman? He's a cricketer, isn't it? A good cricketer, but he has been targeted in the social media. Why? He just slipped the catch. See, that is the effect of social media. You will just blast people without knowing what it is, what you are doing. Young Indian pacer Arshdeep Singh brutally trolled on social media. Who is controlling? There must be some control over this. That is where we have to think about concepts of artificial intelligence. Already, these concepts are used by Facebook, WhatsApp, and others. You will come to that. So, what I am trying to say is, even in the public, even in the society, this evil effects of social media is happening, like what we saw in the case of Arshdeep Singh. How is this happening? Because they spread news easily. News travel faster in social media. Once the news is uploaded, people have free access to read, like, and share it. The more people who share, the wider the scope of the news, wider its impact. So, those are the factors which call for some amount of control, some amount of limitation, whether everything can be made open to all and whether it can be published to a larger audience, which will have its own detrimental effect also. So these are some of the advantages, things like that. The last one stage with the packed daily life schedule, real-time communication with family and friends is getting smaller. The father and son, they don't get time to communicate face to face. They use WhatsApp. What a pity. The social relationship, the family relationship will dwindle. That's why I have the question mark there, whether it is good or appropriate. On the marketing side, people utilize social media as a powerful platform for marketing, share some good content for the followers, and lead them to the potential customers, emerge as a powerful platform to market. Here also, we cannot fully assimilate what has been advertised in the social media. We have to do our own critical thinking, like what Pandit Jawaharlal Nehru said long back. You must have a computational thinking to some extent, or towards intelligence. Don't accept anything without proper reason. Scientific temper, that was the word coined by Pandit Jawaharlal Nehru long back in his book, Discovery of India. The negative side of social media, mostly geared due to excessive use of the platform and lacks users' understanding, as also users' ethical behavior. That is, anonymity often creates offending and objectionable material in public view. We can conceal our identity in social media. We can have an account in somebody else's name or some fictitious name. So nobody is responsible for what is happening. Nobody can be sued for it. That is a factor which has been to some extent corrected through various IT rules and regulations. So our thought is, can AI impact social media interactions more positively? That is where young researchers like you should explore. Already it is in use, but not all problems have been solved. There are some or several problems which are yet to be solved. Even Facebook and WhatsApp people, they are also towards making it more and more reliable and accepted. So that is why I wanted to connect artificial intelligence and social media, which I feel would be in tune with the conference. So now we say artificial intelligence can be used. That is what I have been trying to make. When you think about artificial intelligence, I came across a report from Stanford, October 25, 2011. Stanford's John McCarthy, seminal figure of artificial intelligence, carries the name. He is considered as the father of artificial intelligence because he has coined the term artificial intelligence. McCarthy created the term artificial intelligence and was a towering figure in computer science at Stanford most of his professional life. In his career, he developed the programming language, is the artificial intelligence programming language, played computer chess via telegraph with opponents in Russia, and invented computer time travel. Great computer scientist, John McCarthy. I think it is his junior colleague who later became an authority in artificial intelligence, Algebraic Topology. He had visited India. In 1989, there was an international conference on artificial intelligence, which I had the privilege to attend. It was in Hyderabad. This Lord Algebraic Topology. He is again a professor at Stanford, still alive, but perhaps quite old. He was present at that conference. That was in 1989. He was giving very initial concepts in a most understandable manner for the young participants there. Now, what did McCarthy say? The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate. That is the concept of artificial intelligence. We have to define the problem, we have to define what is the requirement in such a manner that it should be done by the machine as it is done by a human being. That's what computational thinking is. Algorithmic thinking or computational thinking. You define the problem in such a way that it could be solved by a machine. Make machines do the job. So this concept is to be adopted in the context of social media. Problems in social media need to be solved without human intervention as far as possible. That is our problem, which I am posing to you. In 1955, McCarthy authored a proposal for a 2-month, 10-person summer research conference on artificial intelligence. The first use of the term in any publication. That was when the term artificial intelligence as a phrase was used. The Association for Computing Machinery honored McCarthy with the AM Turing Award in 1971. What is a Turing test? The completely automated public Turing test to tell computers and humans apart. What is it? Are you familiar with that? When you try to do an online transaction, you give your username, you give the password. Then a third component is there. What is it? Captcha. What is captcha? This is what captcha is. Completely automated public Turing test to tell computers and humans apart. Short form is captcha. So the Turing test is inherited. That's why it is widely used everywhere. Whenever there is an online transaction, you give your password, you give your username, and then there is a captcha to see whether you are a machine or a human being. That's what the power of captcha. What is this? Some examples. Unmanned drones, no need of human intervention. You can set everything and then the machine will do. That's what in space, I guess all of us, that's what is happening. Initially everything is set and the machine will do all according to the sequence in which it has been programmed. Self-driving cars. What is the issue with self-driving cars? Well, it has not come to our country. What happens is an accident? Who is the person responsible? That is the main issue, which is yet to be solved. Whether it is the system or whether it is the person who has designed the system or whether it is the environment in which the car has been moving. So there is a debate going on to fix the responsibility. Some mishap happens with respect to self-driving cars. Smart assistants, spam filters on email, all those things are there. Now, our context, how AI is impacting our lives. You see the second term of smartphones, all of us are using, social media platforms. That is where one application of AI could be very effectively used. You have to use it. You have to formulate the search problems, investigate them, and try to find a solution. That is the message that I want to give in this particular session. Well, the other things are all e-commerce, autonomous vehicles, security and surveillance, navigation, banking and finance sector, smart home. You're all familiar with this. Everywhere this artificial intelligence is adopted, supplied. Security and surveillance, your face recognition and things like that. Navigation, your geographical, GPS, your mobile is called GPS. Banking and finance sector, as I said, all sorts of online transactions can be done. Smart home, autonomous vehicles, smartphones, etc. I think this is more or less more concerned about artificial intelligence, starting from healthcare, going up to entertainment and e-commerce. Education also very much influenced by artificial intelligence. Social networking services number of users as of January 2020. Just to show the extent in which social networks and social media are important. Facebook has got 2,910 millions. WhatsApp has got 2,000 million users, like that. So the popularity of social media is exhaustive. That is why if you formulate a problem which is related to social media issues, and then you can face very boldly the question that PhD research is not towards solving problems in the society. That is a question which is not really posed. We are all doing theoretical research. No advantage for the common man. That is one question needs to be addressed by the researchers. So that's why I thought of talking about social media. So with this, we should be convinced that social media is quite relevant for our research purpose. What is our problem with respect to social media? Billions of items, you all know, photos, comments, sensitive data get uploaded to social media, which are owned by multiple users. Once it is in the social media, it can be accessed by those who are authorized to have an account in that. It is often the case that only the user who uploads the items can set its privacy, which indicates who can access the particular. So from artificial intelligence, we went to social media, and now we are moving towards the problem. What is the problem with social media? Data information so uploaded is considered as the bread and butter of social media. You all know that. This rather unfettered exposure of data or information has emerged as a serious problem, owing to the fact that other users in the group or network may have privacy preference. Social media privacy, that is the point where I want to focus on. It could be conflicting the one who has uploaded and set the privacy preference. I am uploading something, I can set the privacy norms on that. But when I share it with somebody else, he is in possession of that. What is he going to do with that? I have no control. That is why we have to look at. What is privacy? Is it the same as security? Security and privacy, they are not one-to-one the same, but there are overlaps. That's what I want to say. Security is defense in depth, DLP, data loss prevention, security, information and event management, accuracy, integrity, access, availability, accountability. These things form into privacy also. Where privacy has got a more broader implication, notice, consent, openness, relevance, proportionality, regional sensitivity, and so we have to have a distinction between what privacy is and what security is. Security may justify privacy to the extent that what is the security pattern that you are giving to a particular situation. If you are making it secure, that means only most authorized people will be able to access it. That is one aspect of security, which will guard the privacy aspect as well. But when you look at privacy alone, the security aspect is not there. We look at our own right of privacy. Now, privacy has been accepted as a fundamental right here. There was that Justice Krishna Commission report and all that, based on which these IT laws were made by the Parliament. And according to that, privacy is almost fundamental. It's a fundamental right. That's why when we have this medical data and healthcare data, it has to be made anonymous. It should not be related to a particular name. Name should be X, Y, Z like that. A person's name and address. The identity of the person should not be related to the particular data that is available in the public domain. Maybe the age factor we can give so that the research can be related with respect to age and all. Those things are happening. But the data has to be made anonymous. Nobody shall know to whom this particular data is attached. So our problem from here goes into multi-party privacy, which is often having the acronym MP. Multi-party privacy aims to facilitate the coordination of collectively held privacy boundaries by all individuals that co-own a data item online, as the privacy of all of them may be at stake depending on with whom the co-owned data item is shared. I think that statement is clear in itself. There is a data item which is uploaded into the social media that may be relating to several other persons as well. So if you are giving the privacy or if you are giving trust to the privacy part, you are giving trust to the privacy part, we have to look into the aspects when these content are handled by the other users. That's why we call it multi-party privacy, MP. So we come to multi-party privacy. This is this slide. Okay. Users in social networks connect with one another and share content. A privacy conflict happens when two users disagree on who else should see the content. That is where our multi-party privacy is applicable. Multi-party privacy particularly focuses on supporting the detection and resolution of multi-party privacy conflicts. I will say what it is. When individuals whose privacy may be affected by the same co-owned data item have conflicting privacy. I may assess the privacy pattern to a particular data that is uploaded in the social media. It is shared among few people in groups. When it is having access by another person in the group, we have no control whether he is sharing it with somebody else, where the initial person who has uploaded may not like it to be shared, or the person who are involved in that item may not like it to be shared by others. That is where our multi-party privacy comes. So in social media, remember, multi-party privacy is an important component. But these are all things which we practically come across every day, but may not have thought much from the research point of view. Here's an example. Items shared through social media may affect more than one user's privacy. For example, photos that depict multiple users. There can be a photo. Somebody, if we are going out with friends, taking selfies and posting on the social media. It's happening quite common. Events in which multiple users are invited. The lack of multi-party privacy management support in current mainstream social media infrastructures make users unable to appropriately control to whom these items are actually shared. Well, if we go out with friends, take photographs and all that, some of us may not like this to be shown to our parents. That happens. That is where our control comes in. So I am giving you, I should say, nasty example. There are implications for that. One person may not like this to be shown to others. That is where our multi-party privacy comes in. The lack of multi-party privacy management support in current mainstream social media infrastructure make users unable to appropriately control to whom these items are actually shared. That is our problem. Whether we can control the way in which a particular item. Here I have given an example of a photo. Can be a good research result as well. Can be a good collective intelligence output as well, which we may not like others to be given access to. Computational mechanisms that are able to merge the privacy preferences of multiple users into a single policy for an item can help solve this problem. Can machines do this themselves? It should be able to, that's what we saw. The company was saying, whatever human being can do, can be done by machines. So if you are able to solve it manually, by human intervention, it should be possible to be solved by an intelligent system, an intelligent machine as well. That is where we have to look at. So this is our motivation. We have time. The vast amount of data in social media is user generated and personal most of the time, which clearly calls for appropriate privacy preservation mechanisms that allow other users to benefit from the social media while adequately protecting each one's personal. That is the crux of the problem. There is a group who is providing some information on the social media. In terms of, it can be a photo, it can be a text, it can be some research result as well. Whether it is used properly for the purpose for which it is intended. The main challenge is to propose automated solutions that resolves possible conflicts among the users involved in an item. Example, all users depicted in a photo, so that users are forced to negotiate manually. That's what happens now. Negotiate manually as quickly as possible, thus minimizing the burden on the user to resolve multi-party conflicts. Can I have a little water? So you look for AI-based approaches, particularly with the intense research happening in respect of machine learning. That is our progress. You researchers will have to look into it. Look for AI-based approaches, particularly with the intense research happening in respect of machine learning. Data scientists sort of expanding it, and others. When we cite in our publications, we always say data. Ram Kumar data, like that. Data stands for each idea. Need for the development of novel privacy enhancing techniques and mechanisms to help users manage manage multi-party privacy. Develop mechanisms and embed them in highly usable tools ready to be utilized by end users. Just as we very comfortably and conveniently use WhatsApp in order to make video calls, international calls, etc. It should be as simple as that. we should be able to solve the issues with respect to multi-party privacy, so that the privacy of each and every individual who is part of the team, part of the group, is made secure, is ensured, privacy is ensured. It requires probably an interdisciplinary approach due to the complex nature of MP and social behavior. A lot of factors are involved in it. Maybe we have to study, or we must have some idea about the profile of the persons who are involved in it. To some extent, the thought process, what is its approach? Well, in this online transactions and all that, when you make a lot of purchases online, the harm is that a person or a group who is interested can make a profile of your spending habits. What are you spending on? Are you spending too much on your dress? Are you spending too much on books? Like that, because all these things are available on record. So that is one issue which is connected to these things. Social behavior, that's what I mean here as social behavior. Now, what could be the methodology? It has to emerge. A generalized proposition shall be to identify conflicts. First, let us see whether there is some conflict, and to resolve them by applying a distinct conflict resolution strategy, depending on the concessions that users may be prepared to make in various scenarios. Concession, because in the first instance, we may think, no, I am not going to share with this anybody else. There is a scope for negotiation. A person who is involved in that may argue with you or may plead with you. So what is the problem in sharing that? That is what negotiation is. This is happening manually, human intervention, but this should happen in the system, in an intelligent system. Maybe you are making use of a bot, a chat bot sort of thing. Mediator. Sometimes in literature you come across what is called a mediator. Mediator initially inspects the personal privacy rules of all users involved, looking for possible conflicts. If conflicts are observed, the mediator proposes a solution to each access attempt in accordance with set of concession regulations that model how users could absolutely negotiate in this way. That gives an idea about what the system should be working on. It should be capable of identifying the conflict, it should be capable of simulating the environment, then it should be capable of negotiating with the various entities who are involved in that, so that an amicable solution is obtained, a resolution is obtained. This has the ability to lessen the amount of manual intervention. Our attempt is to reduce the intervention of human beings to reach a pleasant solution for all concerned users in the multi-party conflict. A stepping stone towards computerized resolution of conflicts in multi-party privacy control for social media. That is our attempt. That's why I have shown it in a different color. I think this probably I can see. Primarily, this is a human activity involving cognition and intelligence, or cognitive sense. That is what in earlier instances distincts a human being from a machine. Machine is yet to have proper cognitive sense. I think the artificial intelligence research is oriented towards that part also, in order to imbibe some cognitive sense in the machine. You know what it knows, you learn from the environment and go further in acquiring the knowledge. Can AI machine learning could be of help? That is what we have to explore. Current approaches are either too demanding or only consider fixed ways of aggregating privacy. Some review results I am showing here. What is the approach? A short description and what is the main drawbacks. I think it's too small for me to read. Users, the first one is manual. Users are provided with a way of detecting multi-party conflicts in business, and they can manually resolve them when detected. Manual intervention. Another approach is auction-based. Users gain fictitious money they can invest in auctions, bidding for the most desired sharing decisions for co-owned items. It's also reported in the literature that money part can be yes or no. Without the money part also, you can do that auction. Aggregation based. Individual privacy preferences of all users are aggregated using a rule or set of rules to produce a joint sharing decision. That's also important. Adaptive. Different situations are modeled. Models they have copied from the public domain. Based on a number of factors and a different sharing decision is suggested depending on the situation. Another aspect is more towards your area, mathematics, game theory. Users or automated software agents negotiate a solution following an established protocol. Both the protocol and the negotiation strategies are analyzed using game theory solution concepts. I'm not a mathematician as I said, so you will be more conversant with that. Fine grain. Users define individualized access control decisions. Access control decisions. Well, those who have gone into operating system, we have ACL, access control list, which will control the access to various resources. This is a manifestation of that. Access control decisions or personally identifying objects within a photo. For example, users deciding whether or not their faces are blurred. Built in television, they show something, the face will be blurred. That also is part of what we come across as reported work with respect to social media. I'm not going to the disadvantage part. So this is the crux of what the work that is going on with respect to social media and involving some amount of computation and intelligence. This has appeared in an ACM journal. I don't have the reference with me. Probably, if you are interested, I can engage. Some automated approaches for conflict resolution. One is uploader overrides. The conflict is solved selecting the action preferred by the user that uploads it. The person who has uploaded the item is the master. So we have to approach him in order to solve the conflict. This is the strategy currently followed by most social media sites like Facebook, etc. Another one is majority voting. The conflict is solved selecting the action most preferred by the majority of the negotiators. So the minority will be at a disadvantage. Their preferences may not be adequately considered. Those may be majority voting. That is our democracy. Veto voting. If there is one negotiating user whose most preferred action is denying access, the conflict is solved by denying access to the agent. What is happening in US? There are some countries who have got veto power. So very genuinely, somebody will come up with a solution which is very genuine, which should be accepted, but China or maybe US may not like it, they will veto it. So that sort of thing also happens. This is a disadvantage of many who are part of that system. Well, these are the disadvantages and advantages of those things. I will skip this. Yeah, explanations on that. I will skip it. Literature reports the use of a mediator that detects conflicts and suggests a possible solution. This is what you have to automate. In most social media infrastructures such as Facebook, Twitter, Google, and the like, this mediator could be integrated as the back end of social media privacy controls interface, or it could be implemented as a social media application such as Facebook app that works as an inference to the privacy controls of the underlying social media infrastructure. That's what I said. Already some things are there. It is not complete in itself. Can bots be made use of? That is one thing that researchers will have to look at. The chatbox is a type of software, as you all know, that can help customers by automating conversations and interact with them through messaging platforms. Instead of a human mediator, there can be a chatbot, what you call a bot, or something like that, similar to that, which is software driven. Let's keep this. What is the process the mediator should know? Identify we have already understood what the role of the mediator is. Let us go to the last three statements. The mediator proposes a solution for each conflict found. To this aim, the mediator estimates how willing each negotiating user may be to concede by considering her individual privacy preferences, how sensitive the particular item is for, the relative importance of the conflict target. These are the criteria, some of the criteria which could be identified. Based on this, you have to develop the system. Why am I using her here? Her individual privacy, not his. How sensitive particular item is for her. The general English, if you associate that person, if you do not know what gender the person is, they will write her. That is the norm that is followed in modern English. Ladies get the preference problem, that's it. Here are a few things that aren't allowed on Facebook. You all know hate speech, credible threats or direct attacks on an individual or group, content that contains self-harm or excessive violence, nudity or other sexually suggestive content, fake or imposter profiles, spam. These things are not allowed in Facebook. Isn't it? How is it done? They are already making use of artificial intelligence concepts, but they themselves say it is not complete. I'll come to that. How does this filtering happen? AI concepts are employed, but not always self-reliant. It is not complete. It is supplemented through human review teams. There is some mechanized part, there is some human intervention part as well. Sometimes deficit in communicating admissible reasons for objection to the agreed use results in legal challenges. Because we have to explain. See, these days people are very much fond of making a legal issue of everything, file a suit in the court, and then the whole thing will be examined, and we should be able to properly justify our action. That's why I initially mentioned about explainable artificial intelligence. People on Facebook and Instagram post billions of pieces of content every day. Okay, even with thousands of reviewers around the world, it's impossible for them to review it all by themselves. That is where meta intelligence comes. So more and more work has to be done, more and more research has to be done in order to make it more and more less dependent on human intervention. I'm having a quote here. We remove millions of violating posts and accounts every day on Facebook and Instagram. Most of this happens automatically. That's already there. With technology working behind the scenes to remove violating content, often before anyone sees it. So that is already happening. They give lecture in the class, this does not happen. I do not know. Discipline. Talk like this, I am always tempted to bring some water into it. Normal class like this never happens. Other times our technology will detect potentially violating content, but send it to review teams to check and take action. It is not entirely done by the system. Sometimes something which is not capable to be done by the system is offers to the review team. This work is never finished. People will keep trying to evade our technology, so we need to keep improving. That is our present status. Already some systems are there, which is not sufficient. We have to supplement that. We have to make it more capable, so that things will be. And stop in and refer. So you have to develop mechanism for detecting and resolving privacy issues in social media based on cutting-edge concepts for privacy negotiation, obeying the need of human intervention in a given situation. Explore the possibility of cognitive understanding, identify critical components of a particular posting, assign privacy rating and decency index. That's a new term being coined. Privacy rating, you can give different rates for that. And decency index. The content in the social media should be decent. There can be different levels of decency. It can be extremely decent, it can be low in decency. So the new term is being coined, what is called decency index. Can this be done based on a recursive training crafted to an empirical process of sample survey? Will the concepts of machine learning help? That is why probably I might conclude. Yeah, one slide on this. Make use of, say, as I said earlier, explainable artificial intelligence or interpretable artificial intelligence or explainable machine learning is artificial intelligence in which humans can understand the decisions or predictions made by the. We have to justify in what manner has he arrived at this particular decision. Particularly, as I said, in legal scrutiny, this reasoning is very important. We have convinced the court that this result has been, or this action has been taken based on such and such factors. It should be clear. It should be clear and admissible. That is where our XAI will help. It contrasts with the black box concept in machine learning, where even its designers cannot explain why an AI arrived at a specific decision. This neural networks and all that, based on these several layers. Finally, we do not know what are the factors that were considered in order to arrive at that particular decision. In order to overcome that, only this new area of artificial intelligence, what is called explainable artificial intelligence, has emerged. Often legal questions arise why a particular posting has been put to task. Judicial interventions are also not uncommon these days of increased legal recourse to redress one's grievance. We are tempted to go to court for every minor issue. Proper and convincing justification may have to be furnished. So what I have tried to give is a glimpse of the present scenario of social media. What is privacy? What is multi-party privacy? How the issues can be solved? How we can adopt concepts of intelligence systems and artificial intelligence. That is because of my talk. All the best to you. I wish to acknowledge several contributors from where I have taken this material from. Okay. It was an interesting experience to face you all and share my thoughts with respect to this particular topic. Thank you very much for your attention.
On behalf of the Department of Mathematics, CETA, and everyone present here, and also on behalf of the audience present online, I wholeheartedly express my gratitude towards Dr. K. Paulos Jacob, sir, for your time and sharing your knowledge. Thank you once again.
Thank you.
Feedback link is shared in chat box. Please submit your feedback now itself. Also, the next session, the tutorial session will start at 11:15. Thank you.